This tiny rock has the power to light up an entire city for years. Yet the same material can wipe that city off the map in minutes. This mysterious element is uranium. But what exactly is uranium? How was it discovered? And why does it contain so much energy? Let's find out with Labib. Uranium is a naturally occurring radioactive element with atomic number 92. It is one of the heaviest elements found in nature and is present in rocks all around the world. Although it looks like an ordinary metal, inside every uranium atom lies an enormous amount of energy. The story began in 1789 when German chemist Martin Heinrich Klaproth analyzed a black mineral called pitch blende. During his experiments, he realized he had discovered an entirely new element. Since the planet Uranus had been discovered only a few years earlier, he named the element uranium. Interestingly, Klaproth never isolated pure uranium. More than 50 years later, French chemist Eugène Pélagot successfully produced pure metallic uranium, proving that Klaproth had actually discovered uranium oxide. At first, uranium had very little practical value. It was mainly used to color glass and ceramics. Under ultraviolet light, uranium glass glows with a beautiful green color, making it popular for decorative objects. Everything changed in 1896 when Henri Becquerel accidentally discovered that uranium emits invisible rays without any external energy source. This unexpected discovery marked the beginning of nuclear science. Marie and Pierre Curie expanded Becquerel's work and introduced the term radioactivity. They also discovered two new radioactive elements, radium and polonium, while studying uranium ores. In 1932, James Chadwick discovered the neutron. This tiny particle would later become the key to unlocking the incredible energy hidden inside uranium atoms. In 1938, Otto Hahn and Fritz Strassmann bombarded uranium with neutrons. Instead of creating a heavier element, the uranium atom split into two smaller atoms. Lise Meitner later explained this process and named it nuclear fission. When uranium splits, a tiny amount of its mass disappears. According to Einstein's famous equation, E equals mc squared, that missing mass is converted directly into energy. Even a tiny loss of mass produces an enormous amount of power. Natural uranium exists in three forms called isotopes: uranium-234, uranium-235, and uranium-238. They all have 92 protons, but different numbers of neutrons. Although uranium-238 makes up over 99% of natural uranium, it is uranium-235 that is ideal for nuclear reactors, because it can easily undergo nuclear fission when struck by a slow neutron. When one uranium-235 atom splits, it releases 3 more neutrons. These neutrons split more uranium atoms, creating a chain reaction. This process releases tremendous amounts of heat. Inside a nuclear power plant, this heat boils water into steam. The steam spins turbines connected to generators, producing electricity for millions of homes without burning fossil fuels. The same chain reaction can also become extremely dangerous. In nuclear reactors, the reaction is carefully controlled. In nuclear weapons, the reaction happens almost instantly, releasing devastating energy in a fraction of a second. Nuclear energy produces massive amounts of electricity with very low carbon emissions. However, radioactive waste, reactor safety, and nuclear weapons remain major global concerns. From an ordinary-looking rock to one of humanity's most powerful discoveries, Uranium has completely transformed our world. Whether it becomes a source of clean energy or unimaginable destruction depends entirely on how we choose to use it. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more fascinating science videos.